Okay, so here we go. We're going to go ahead and start over again. All right. The first thing we're going to look at is a Jamboard I created last night with our answers to our homework assignment. Okay, so 45, there's the prime factorization. 3 times 3 times 5 is the unique combination of prime numbers that builds a 45. 2 times 19 will build a 76. I had to bust that 76 down. I knew it was divisible by 2 because it's even, but I just didn't know what it would be. So I did some division. Do you see how I did that? Okay, and then I got a 38, but I wasn't quite sure, so I had to do some more division. And then I found 19 on my chart and found out what it was prime. Since they have 0 numbers in common, none of these are repeated over here that are over here. We know the greatest common factor those two numbers have is 1. That's what happens when the two numbers have no factors in common. The next one was 16, 48, and 88. They had tons and tons of stuff in common. 16 had lots of 2s, 48 had 2s and 3s, and 88 had a 2s and 11s. And each one of them, when I stacked up their prime factorization, had 3 2s. And we know 2 to the 3rd power is 8, isn't it? 2 times 2 is 4, times 2 again is 8. Okay, hopefully that's what you got. 6 can be broken down to a 2 times a 3. 15 can be broken down to 3 times 5. And when we look at those prime factorizations, we both notice that 3 has been repeated in each of them. So we have 3 for the greatest common factor. Since it's only one thing they have in common, we have no multiplication to do. On 30, we had a 2, a 3, and a 5. And on 58, we had a 2 and a 29. The only thing they had in common was the 2, so the greatest common factor was 2. For 168, 48, and 24, they had tons and tons of stuff in common. All right, so they each had at least 1 2. They each had at least another 2. They each had a third 2 in common, and then they each had a 3. And 2 times 2 times 2 is 8, times 3 is 24. The greatest common factor for that question was 24. So what we're going to do today, hopefully your teacher has had a chance to pass out those papers, and they can just let me know when their class is ready. All you need on your desk today is your new worksheet, the one that says listing multiples for all the numbers on one side, and then make factor trees for all the numbers. And it has to do with LCM. Looks almost like the one we had yesterday. Let me know when you're ready to start. All you need is that pencil and the worksheet at your desk. Well, you also need a thinking brain.
Where's this card?
Okay. Okay.
Alan's class is ready.
Okay.
Mueller's ready.
All right, thank you very much. So we're going to go ahead and get started. Now, just leave your pencils down while we go through the slideshow, okay? Because I'm going to describe what it is the LCM means. I know a lot of us already know what LCM means, but we just need to remember for sure how it works, okay? So LCM stands for least common multiple. Multiples that are shared by 2 or more numbers are called common multiples. The least of the common multiples is called the least common multiple, LCM. You can find the LCM of 2 or more numbers simply by listing their multiples or by using prime factors, okay? When you're dealing with fractions, we call these least common denominators. We need those in order to add and subtract numbers that are fractions, okay? Hello? Oh, there it is. So if we're trying to find the LCM of the number 4 and the number 6, we start listing their multiples. Don't confuse multiples with factors. Factors are the pair of numbers that build a number, right? Multiples are like reading across the multiplication chart next to the number. So for a 4 and a 6, if you look at your multiples of 4 and 6, you're going to see that they are, for 4, they would be 4, 8, 12, 16, 20, and so on. Okay, that's what I mean by multiples. They're way different than factors. Okay, and the multiples of 6 would be 6, 12, 18, 24, and so on. Okay, so if you look at those lists of numbers, you're going to notice they have lots of numbers in common in those lists. All right, and I highlighted them in blue. The first number they have in common, the least common multiple, is 12. Okay, so we're going to use prime factorization to find the LCM. Just as though we did GCF, we're just going the opposite direction. Now we'll use it for LCM. Factor trees are what we do to find prime factorizations, right? A 6 is built by the prime numbers 2 times 3. A 4 is built by the prime numbers 2 times 2. Then we ask a couple of questions in order to get our LCM. We ask first, what numbers are appearing in those prime factorizations? There's 2s and 3s, right? How many times does each number appear in any one of those prime factorizations is our next question. Well, we see once the 3 appears and twice, 2 times in this one, the 2 appears in that prime factorization. Okay, so once we've asked those questions, then we can go ahead and think about it. Since the 2 appears once, no, the 3 only happens once and the 2 appears twice, we take the 2 times the 2 times the 3, and do we get the same answer? Yes. So that's what we do to find the least common multiple. It's a little different than finding greatest common factor because all we needed was whatever they had in common. But in this case, we want to take all those little building pieces and make sure they have everything multiplied back together again. Okay? So here's another example. I'm going to look up here at the list method. Okay? So it says find the LCM of 12 and 18. Here is the list method. 12, 24, 36, boom. That's the first time they have a factor or a multiple in common, right? And then 48, 60, 72, there's another multiple they have in common. They have infinite amounts of multiples in common. But when we worry about multiples, we want the smallest multiples they have in common, okay? The other method is to build those factor trees. 12 is built by multiplying the prime numbers 2 times 2 times 3. 18 is built by multiplying the prime numbers 2 times 3 times 3. So since there's 2s and 3s, we answer the question, what numbers are there? Well, 2s and 3s. What number, or in which prime factorization do we have the most 2s? The 12, right? The 2s repeat twice, so I need at least 2 2s. And in the 18, the 3s repeat twice, so I need at least 2 3s. And when I multiply 2 times 2, I get 4 times 3, which is 12, times 3, which is 36. And that gets you that same result. Okay? So the reason why we do it this way with prime factorizations is because when you're working with these smaller numbers, there's less chance also of getting calculation errors unless you build your factor tree incorrectly. But we're going to get so great at factor trees that we'll never make mistakes in factor trees. Where we'll make mistakes might be in our calculating of really, really big numbers. So we want to avoid having to do a bunch of those calculations. So on your worksheet, you have all of these questions, don't you? It says 6 and 15, 11 and 12, 18 and 45, 12 and 18, and then 6 and 20, right? Do you see the side that says using lists of multiples for all on this side of the paper? That's the side of the paper I want you to be on. It is the side of the paper that does not have the story problem on it. So we're going to start on the side of the paper that does not have the story problem. Look and check and see if your neighbor's on the right side of their paper. It says at the top, using lists of multiples, and then that side does not have the story problem on it. Okay, awesome. Looks like all of my kids are on the right page. So now I'm going to go back to that Jamboard thing. And instead of using my iPad, I'm going to attempt to use the Jamboard today to work through some of these problems with you. We'll start with about halfway down the paper. We had 18 and 45. Was that one of the examples? I don't think it was. Yeah, let's start with that question halfway down the page. Okay, so we'll start, I don't like that size. I don't like that size. I like the fatter size numbers. Okay. So 18, let's do the prime factorization for that by building a tree. We could pick 2 times 9 or 3 times 6, right? Okay, are both my numbers in the bottom of my tree prime? Nope, the 3 is prime, the 6 is not. So I need to put 2 branches under the 6. 6 is built by multiplying 2 times 3. Beautiful. Mrs. Franzen? Yes. You're not supposed to be making factor trees on this side of the paper. Oh, shoot. Okay. Mrs. Franzen, pay attention in class. Okay. So erase that factor tree because I absolutely love doing these with factor trees. I do not love doing them with lists. I'm so sorry that I led you guys down the primrose path. You guys just want to drink from the fountain of knowledge, and all I do is make mistakes. I apologize. Okay, so we're using lists instead. All right, we'll start with the number 18. 1, 8. So all we have to do is list all the factors of, or not factors, all the multiples of 18. Well, 18 times 1 is 18. 18 times 2 is 36. Not all of us know that fact. So we would have to be writing the multiplication problem down off to the side, wouldn't we? 18 times 3. So 8 times 3 is 24, but 18 times 3 is not 24. 52.
Times 2.
54?
We're going to have to multiply it out, guys.
102. I mean 104.
18 times 3.
54. Got it.
Okay. Oh my goodness, this is going to take forever. Okay, what was our other number then? Our other number was 45. So we just now got a multiple of 18 that is big enough to have possibly worked, but it doesn't. So I have to keep going. 18 times 1, 18 times 2, 18 times 3. What's 18 times 4?
62.
72. It's 72, guys.
Okay, let's not shout, Sai. All right, what's the next multiple of 45? Maybe that's 72. 45 times 2. So that can't be it. Oh, I hate making lists. They take forever. I love factor trees. All right, 18 times 5.
90.
90. Boom. Finally, we get to our least common multiple, don't we? Okay, so copy those down, and then we know our least common multiple here is 90. Okay, awesome. So that's our first answer on the front side. Let's look at 12 and 18. Gosh, I think 12 and 18 was on my, wasn't 12 and 18 one of the examples?
Yes.
Oh my goodness, it was one of the examples. How handy is that?
Easy.
All right, so since 12 and 18 was one of my examples, we're just going to copy the list method on this side. So we'll put down 12, 24, 36, 48, 60, and 72 there. And then we'll also put 18, 36, 54, and 72, and we'll write our LCM equals 36, right? Okay. So boom, 2 of your homework questions are done. Do you suppose on the other side we also have an 18 and a 12?
Yes.
We do. So once you get the lists written on this side, guess what I want you to do?
That's
I want you to make sure to do your factor trees on the other side, and then also write LCM equals 2 times 2 times 3 times 3 equals 36. Okay, so I have to see these factor trees on the back side for each of those numbers, and then I also need to see this. 2 times 2 times 3 times 3 equals 36.
The other page.
Okay. So this is the side you need to do the factor trees on.
Also?
Yep.
That side?
Yep. So show these factor trees, and then also show this, Rebecca. 2 times 2 times 3 times 3.
Okay. I got that.
Okay. Sorry about that, everybody. I'm hoping you can still see it okay. I think I'll blow it up just a little so you guys can still see it, because I want to. Why does that make it smaller?
it made it small.
Rafe, are you Captain Obvious today? Sorry, I shouldn't pick on students. That is really mean of me. Super mean. Will you forgive me?
No.
Promise? Okay, so now we're on to the next. I want to do one more. Let's do the one that says 11 and 12. Again, we're going to be on the side of the paper that does not have the story problem. Make sure you're on the correct side, and then just double check your neighbor to the right and left of you. So on this side, we're going to do the one that says we're trying to find the least common multiple of 11 and 12 using the lists, okay? So let's just start. 11s are easy. 11s super easy. We can just start listing like crazy for 11s because the multiples of 11s are easy to do. We've got 11, 22, 33, 44, 54. And I need to save a lot of room because I know in my head what it is. And I know this list has to be atrociously long before I run into the number that I need to run into. forgot what 11 times 10 is. It's 110. Why did I forget that? Because I get nervous when I'm presenting, you guys. My tummy kind of starts hurting. I worry about the technology working for you guys, whether or not I make any sense when I'm rambling on and on and on up here.
I started multiplying my lines.
So 121, what's after 121?
131.
132. Yeah.
Times 1.3.
Wait, I know.
And then it's 144, and I finally got to the number I needed to get to. Okay. Not to let the cat out of the bag or anything. Let's do the multiples of 12 now. 12. 24. I have these memorized. I would hope that my 6th grade group makes it a point to memorize the multiples of 12 as well. What's the next one after 48?
60.
Good. Car loans are usually 12 times 7, 72 months. Did you know that? 6-year car loans, usually if you buy a brand new car. What's the next one? Next one? Next one? Next one?
Mrs. Franzen,
Yeah.
my class says that you made a mistake on that first row, that 144 should be 143. Are they correct or are you correct?
Well, what is 11 times 11?
121.
11 times 12.
Okay.
Okay. Oh, look at that.
Yeah.
Okay, well, let's see. Let's keep going. I'll pull up my calculator in a minute if we don't agree when we get there. Okay, we've got 12 times 9 here, don't we? 12 times 10? Okay, what's 12 times 11?
She's right. No, it's not.
Okay, do you see? We're going to grab our calculator and we're going to analyze this mathematics here. So we're right here with 12 times what? 12 times 11, right? Oh, look at that. Okay. Then 12 times 11 is going to be the same thing. So what would 12 times 12 be? Yeah. So 12 times 3 is, see what happened here? Can brains make mistakes like that? Oh, yeah. So when you're writing lists, you can end up making dumb calculating errors. Whereas if you use the factor trees, which I'm pushing really hard about, usually you're not going to make those calculating errors. Okay. So what number was I missing here now?
133.
Are you sure?
32.
Very good. You tell your class, Miss Allen. Good job. Okay. So what is our least common multiple?
132.
Wow.
Okay. Whereas on the other side of the paper, let's flip our paper over now. Okay. Make your factor trees. Well, 11 Can't make a tree, it's prime. 12. I can make a tree for 12. It is 3 times 4. 4 is still not prime, so I must do a 2 times a 2. Now I have the prime numbers that build 12. Now I need to ask myself that first question. What numbers appear? There's 2s, there's 3s, and there's 11s in our prime factorization. Even if I can't build a tree, the factor that we have is 11, right? So which one has the most 2s? 12 does. How many are there?
2.
So we must have at least 2 of those. Okay, we need at least 1 3, and there's only 1 11. When I multiply that together, what should I get? Well, let's do 40, or 2 times 2 is 4, times 3 is 12, and 12 times 11, we just got done talking about this.
32. 32.
How long did it take to build those trees and do that multiplying? A lot less time than listing a bunch of multiples. Mind you, I'm trying to draw these numbers with my finger and think about not being nervous in front of all of you guys and not making mistakes. So yeah, this is it. Okay. So are you on the side now where you're building the factor trees? You should be. And you should be copying all of this down in the space under the 11 and 12. Okay. And your job today then is to make factor trees on this side to find the least common multiple. And on the other side, you must write those lists to find the least common multiple. Okay? And that would be due for tomorrow. Now, if you have any struggles or any questions, I'm going to be in my classroom at lunchtime. So when you guys have playground time, if you don't have to go to another teacher, you can come ask me questions then. And then I want you to give yourself some time to try this during your study hall. Don't immediately say, Mrs. So-and-so, my study hall teacher, I need to go see Mrs. Frandsen right away. Because I have a few people that are coming right away instead of letting themselves experience a little bit of that struggle. Remember, we called it productive struggle, where you're like, oh, I don't know how to do this. I'm just gonna give up right away and go see Mrs. Frandsen. Give me about 10 minutes to have a restroom break. Or sometimes with my study hall time, I'm actually waiting for my students to get through the PE line. So give me at least 10 minutes at the beginning of the study hall time, or even 15, and then ask your teacher if you can come see me. But please try it on your own first so that you make your math mind at least attempt to try to solve the problems. Okay, are there any questions?
I can make the calculator go to infinity.
No questions for Mrs. Mueller.
Okay. So
All right, now group is good.
okay, and Miss Lewis?
Hold on, we have one question. I'm getting it.
Okay.
On the word problem, do we need to do the mountain things?
Yeah.
Yeah.
On the word problem, it says at the top of that side of the paper to make factor trees. So at the top of that side of the paper, that means that all those questions need factor trees.
Okay.
Good question. All right, with that being said, then if there isn't any other questions, you know how to reach me on my texting math hotline in the evenings, right? So good luck.